Okay, let's go. New week, um, but same old water. Good morning, Harukanan, by the way. And I thought I had made it so that I shouldn't run ads for the first hour at least, but oh well. And good morning, Fabik, and thank you so much for the donation. Appreciate it. Good way to start the new week. Okay, so um, I just have to summarize the last couple of weeks, I think it is. Um, we we moved we moved over to starting to dabble with the visuals of the water. Got stuck at the blurring of the or the blur effect because it's a little bit more complicated when we have the outlines to take into account. But I think it's fixed now, and we optimized it quite a bit as well. Um, we simplified the amount of renderer features we use in this project down from 5, I think it was, to 2, which is very nice. We managed to do this, right? Outlines. Oops. I think we did. Very nice. Thank you, Fabik. And what's up, Derek? And Harukanan Bezos needs his toilet paper. Yeah, I've heard that's the case. Okay, and now we have moved on to, so when we have the blurring of the water, we have moved on to other parts of the water, but I haven't had any time to look into this during the weekend, but I have thought about one thing, and it's that we're doing this in a very, how should I put this, unstructured and not so planned way. So I just want to open up my water issue, get some text down where I specify what type of visual effects I want my water in this game to be able to produce, and then we can move onwards. So something I should have done in the past. Okay, we have create water shaders issue here, created a long time ago because I've always wanted to make water. Let's see. I just want to get down, I just want to write down a list of all the different effects, hopefully with the correct terminology that we want for the water, and then we can start implementing them, see what we have implemented and what not, and so on. So let's just create a requirements. Yeah, that's extremely weird, Harukanan. I think I should be running. I'm. Just tell me when you're back. And Fabric Blur again. No. Okay, we're gonna skip the blur today. I'm like, if nothing really unforeseen happens, we're not gonna revisit blur for a long while. Okay. Oh yeah, so that's really weird, Harukanan, on Twitch running ads that often. Like, I think I've scheduled the ads in such a way, like the minimum requirement for my channels to not have pre-rolls, because I just want to get rid of pre-rolls. So I think that should be like 3 minutes each hour, and they should always play, or I thought they would only play after the full hour. So 1 hour of stream, 3 minutes of ads, 1 hour ads, and so on. But yeah. And I wonder if I want to split up my water requirements with above water and below water surface, because there's gonna be a lot of different effects, or the effects are gonna be widely different based on if we're above or below the water surface, or I would say below the water surface or on the water surface. But let's call it this. And what do we have? Color based on depth. Let's create it into one of these. Blur based on depth. Definitely want caustics. Real time. Let's see here. Vertex, normal, or let's do it like this. Refraction, vertex, normal, based. Refraction, normal map based. How do kind of, well, yeah, I guess they split them up over that hour. I really thought they wouldn't, but yeah, probably. Me personally, I would much like, as a viewer, I prefer having all the ads in one choke, or whatever it's called, or in a group. Let me just check. I'm just gonna double check real quick and see what ad settings I have. Okay. I don't remember setting this to true, but okay. So the ads manager automatically schedule my ads on my channel right now. It's good that you mentioned it. I will take a look at this after today's stream and see if I can schedule them in a better way instead. Okay. Is that it for below water surface? Ooh, one more thing. Oh fuck, do I want to camera above water surface? Let's keep it like this. Let's just call this on water surface actually, and this is below water surface. And now we have camera below water surface. I'm gonna wait with this one. Or fuck, do I wanna, maybe I wanna split this up into its own, because this one is pretty much it's a separate issue when it comes down to it. So this is more like a full screen effect. Let's keep it here for now. Maybe I split it out from this issue in the future. But let's see, is this everything I want below? I think so. Gonna call it lighting calculations right now. It might become a bit more complicated in the future. We're gonna have... Okay, so if we do this, maybe that the water just in the garden might not... We might not have... Like... It might not be big enough or deep enough to actually create waves that are so big that we have to render them using vertex displacement. We might be okay with just normal mapping up here. And then we want reflection. I wonder if we can start with screen space, and then we can do probe based. I wonder if I should have an issue with probes. Yeah, there. 97. Is this everything we want? No. Flow. Let's just call it flow effect for now. So for instance, if we have a river going downhill, we're gonna have a greater flow of water, so we want to improve, or like we pretty much want to displacement, is that actually the word? Distort vertex. Vertex. Let's keep it that. I know what it means. Okay, so flow effect. This one, I don't know if it's gonna be an effect in and of itself, or if we're just gonna calculate flows at certain points of the water and then adjust these, or adjust the vertex attributes or these parameters in such a way that we visualize flow. And then we want something called, I think I want to call it edge foam or something like that, or it's not going to be foam per se. In fact, sometimes I want foam, but sometimes I just want edge. Jesus, I'm having a hard time finding the words this Monday morning, but I'm just gonna call it edge details for now. also related to blur blur blur. Sort of okay, maybe not. But what I wanted to work on today is this one. So we want to get the normal map working on the water first of all. So that's what we're going to do first. And then we're going to use the normal map data to adjust the UVs, and then we're just going to read. So it's pretty much, we have this half implemented. I just don't know if it's good enough because we haven't really looked at it in motion. But yeah. And then I wonder, we have one camera above water surface. Do I want to split this one even more? We can do purely visual. And I want to call it like that, yeah, maybe. Because what I want to get here later on is proper interpolation between fluid solver states related to water terraforming. So instead of seeing like the level of the water jumping up in different steps, I wanted to, so we calculate one step, and while we're and then we calculate the next step, and when we have those two, we interpolate between them slowly. And I think we're going to do it in the shader, so you will get the water surface will gradually grow upwards, basically. And lastly, which might also be moved to its own separate issue, because I think it's big enough, is we want game objects to affect the water. So when we run down in the water, this should probably be its own. But like, so when we run down in the water, we want the object that is in the water to affect the water surface. So make it move based on the object. Oh, what is this called? Making objects affect water movement. Oh, ripple effector, yeah. Ripples, making objects be create ripples might be true. Oh, might be good enough. I wonder if, because like this one is definitely going to be dependent on another issue as well, because we want objects to affect the game world, like when we're talking about the grass or foliage or water. So we're probably gonna have a separate issue with which creates a movement texture or something like that, which we utilize in the water to get the water to move. Maybe. A lot of things. But it just feels good to have it as a to-do list like this. And I just wanna, what is it? Oh, I can just see the trailer when a rock is slowly rolling into the water and creates a ripple. Yeah. We'll see what we will manage to do. Okay, some of these things way easier than others, but let's start with this one here. And I think we're gonna have the first problem when it comes to normal maps. We can do it like this. Let's see here. Let's jump to the water shader. And what do we have? Grid properties. We're probably going to remove this one soon. Water general, watercolor, water distortion. This one we're not gonna make this into a water or a shader variant. Fabric, by the way, have you heard that Nintendo is suing creators of Palworld? Apparently catching creatures by throwing an item at them is patented. Yeah, I read about it. So I'm a little bit split. Like, first of all, I think I don't think you should be able to patent game mechanics. I just think that's extremely weird. So fuck Nintendo for going after them based on something like that. But then also when I first saw Palworld, I was just waiting for, like, it feels like a lot of their creature designs is a little bit too close to the to other very famous monsters, if you know what I mean. But yeah, what they're doing now, Nintendo, is kind of weird. Hadouken, and then camera pans up against the sun and the title fades in. I should be a director. Thank you, appreciate it. And when the camera pans up towards the sun also, we're gonna feature God rays and I can't find my words today. I don't know what this is, but you know, these yeah, Michael Bay flare effects or whatever it is. Or who is famous for the flare effects? Lens flares, yes. Lens flares and God rays. Okay. Let's remove this shader feature. We don't need to keep it as a shader feature, I don't think. But let's do this. Fabric, they settled out of court. What? Have they already settled? Damn. That was quick. Let's comment this one out for now. Water distortion, we're gonna go water refraction. Distortion bounce. Okay, let's see if we can get a normal map here. I also wonder if I want to do the distortion based on depth. I'm not so sure. We're gonna wait a second with that. But let's see. Water refraction. Variables. Okay, so let's add a texture 2D here. And unfortunately I don't have... we want to add it up at the top as well. Water surface normal map. Is it like this we do it? Ah, 2D, 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 2D. Okay, and right now we only have this normal map to test. I wonder if... Yeah, at the last of this Friday's stream, I was looking through my normals with normal maps which I've used for other objects. And I'm pretty sure I should have... I should be having a nice water normal map, but I couldn't find it, so I must have deleted it. So I wonder, do I want to work with this one right now, or is this not good enough? No. I think this one should work. Let's try it. Okay, but the biggest problem is gonna be, so normal maps, tangent space, and if we want to work with tangent space, or if we want to convert something from tangent space to world space, object space, whatever, we're gonna need the vectors making up the tangent space. So normal, I want to move this one down. So normal, tangent, and bitangent. If I remember correctly, I think that I think that we're not... Yes, we're not calculating the tangents correctly. So let me just bring up my notes. Let's see if we can make sense out of this. So let's see, 1, 2, or let's do it like this. Okay. So when we calculate the normals here, it's a little bit different for water because, okay, so when we do it for the terrain, we always know that all of these vertices will exist, so we can simplify the calculations a ton, but we can't do the same thing with water because this one might actually be below ground, and if that case we need to do something different, or all of these can be gone, so then we need to do something different for everything connected to them and so on. So what we do for the water is that we don't simplify the normal calculations. We take this one and this one, we do a cross product, then we take this one and do a cross product and add them all together and divide. Oops. But if one of them is below the ground level, like we don't have any water, then we just jump over that cross product. So we pretty much get the normal for this triangle. We get the normal for all the triangles, and then we do the average. So if we want to calculate the normal for this vertex, we get the normal for this, these 6 triangles, and we average them out. So if we want to get the tangent, if we want to get a correct tangent here, could we just take this vertex, this vertex, this vertex, this vertex, this vertex, and this vertex, and then average them out? That should be a correct tangent, right? And if we have the tangent, we get the binormal by doing cross product between the tangent and the normal. But I think that's what we want, so that should be pretty straightforward. We can do normal, and then we do vector 3. Let's do a 4 tangent, and we can start by having it as right. Normal instantiated, can we rely on this one for tangent as well? One sec. Terrain point. Compare greater. We should be able to write this one as if P1 compare greater it's not really that much shorter, but I don't even know if it's that much clearer either, but if water is greater than height and water is greater than height. I think I prefer it as this. So if both of these are true, then we do this. The problem here being that we only need, if we want to have the tangent, I think we only need to do it for this one, right? If we want a tangent, we don't care about 2. Now we just care about 1. Okay, so let's, can we do, let's take this one. And we do if so first we check it for P1. If that is true, we want to do the tangent. And I wonder if we can get around this, having an extra if and else. Maybe we can just instantiate this one as vector 4, 0. Or whoops. -1. And then do, so if P1 is above water, then we just do tangent. Fuck, I'm wondering, is this the correct way? Then we get this one, and if we have this one as well, and maybe. I wonder, do we get the same result if we do this? Do we get the same result if we do this? Instead of just adding all the normals together and then normalizing it. Yeah, maybe that's what we should do. Yo Fabic, switching to my computer for some reason chat doesn't work with Safari. Okay, but then I wonder if we want to do... Oh, actually, we're going to have tangent as a 3 because we want to normalize this one later on, and we don't want to normalize it with a 4th component. So we're going to keep it like this, and then we do tangent is equal to... plus equals to P1 vector, yeah. Is equal to P vector minus P1 vector. And then we do, when we set the tangent later on, we do P vector P1 vector. Can we do constructors like this? Tangent dot normalized. Seriously? That feels like something I would like to have. So I wonder if we're just gonna do a extend it. Why wouldn't they have this? Can we do extend constructor? Not inherit. Constructor extension C#. Nah. I really don't want to create, so like, let's just create an extension to vectors and do something, because I don't want to save a, I don't want to dirty this method too much. I don't want to add too much complexity in here, so it would be nice to just have a function where we convert a vector 3 to a vector 4 with an optional parameter, which would be the new w. entry. So probably gonna add some vector extensions soon. Or once, never mind. Vector extensions. And let's see if we can keep it game extensions. I don't know. Or before I implement this one, let's see, vector 3 unity. Let's see if we already have okay. Public static vector 4. Oh yeah, then we don't want to do, what is it, this? Vector 3. Tangent normalized dot to vector 4 minus 1. Okay, let's see. I want to test this. Actually, I want to make sure that this one and this one is correct-ish. So yo, what's up, Diligence Humility? Good morning, good morning. Or good Monday, good Monday. So what I want to be able to do easily is recalculate mesh at terrain point, fluid solver, terrain fluid solver. What the fuck, do we do this now? Whoa, 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 whoa. Okay, yeah. Okay, so when we do update meshes, update vertex data, yes, and then we do update mesh. In update mesh here, I would like to... How can I double check this easily? I want to be able to flip between, because what I want to do here is I want to add mesh dot recalculate normals and mesh filter dot mesh recalculate tangents, and I just want to see what result we get out of this, and then I want to see what result we get of our custom normal and tangent calculations. Actually, we could probably do... How... okay, we could do this. So when we do update mesh here, we have already updated the vertex data. So let's do... for each I was thinking that we could do... So we just loop through all the normals and we do a subtract, like we just find the error for all of them and then we accumulate that error and just see how far off we are. But we're actually gonna get quite a bit of a different result here when we calculate the normals for the water, because we handle edges in a different way. So we can't do it like that, and if I just want to do it purely visual, I want to be able to flip between Unity generated and my generated. We can do... Oh, fuck. Let's do it like this then. Terrain patch. Do we have update? No, we don't. Okay. So let's just add update meshes, public void update, or private. Do we have any test variables here? something like this, and then yeah, something like that, and then we just go to what do we have here? Bitangent, tangent, normal. Yes. Do we calculate set mesh data? Position normal tangent. Fuck, do I want to calculate binormal here, or should we just do it in the shader? Or actually, we just do it in the shader, right? I think we do it in terrain procedural water. Yeah, we just send in normal and tangent, and then this one calculates it for us. Yes, by tangent. Okay, so let's do fragment return input.normal OS. VS, is that what we want to keep? Ah, maybe. Where do we have it? Here. Okay, let's see. So now we should have a flag in terrain patch which we can set. If we set it, we switch from calculating it ourselves to letting Unity calculate it. And if we unset it again, we jump back. Okay. Oh, fuck. It's gonna be hard to. It's pretty much this part. That's the only part I'm interested in, I would say. Let's see. Not visible in scene. The only difference we see here, and that is good. So we handle the edges differently, but this part and this part was unchanged, so that's good. Let's see if we can get it back as well. Okay, so the other way doesn't really work. Why not? So yeah, we put this to true, this one is false, so we get in here. So test A done is equal to true. Okay. And then if we set this one to false, this one is still true. Okay, did this part not work for some reason? We updated the mesh data, but we didn't really update the mesh filter. Okay. And now I want to do the same test, but I want to do it with terrain procedural water. We want to do it with tangent world space. I just want to make sure that these are, that we get the correct normal and tangent before we move on to converting between tangent space and world space and whatnot. Red. Maybe. A little bit skeptical about this, definitely. I'm pretty sure this is wrong, but terrain patch, and then we enable test A. Yeah, it's something like this we want. Okay. Why? Are we going 0 less than neighbors count? Is it a problem of p vector minus p1 vector? I'm pretty sure the direction here shouldn't matter, but I don't know. Yo, what's up, PG King? Good morning, good morning. What the fuck? Are we getting this rough? Mm-mm-mm. One sec. So if we do this one plus this one, bum 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 bum. Yeah. Okay, if we just go X, if we just do X and Z, we should end up. I don't know what I'm missing. Calculate tangent from. It's not really. Left, right, up, down, and then they do this. Okay, so we do this, which I have. Don't we have that in util math? Generate tangent. This is exactly what we do, right? Epsilon, yes. So we calculate the tangent. We just do cross product between normal and world up, and we get the tangent from that. Is that how I want to do it? Like, it feels like we have enough data to just do it the normal way. Generate tangent. Let's see. Let's do it like this. Let's just see what we get. Okay, and then we do terrain, water. So instead of returning this one, we calculate return generate tangent input dot normal world space epsilon 0.001. And this one returns a float 3, so Is the problem yeah, we might. Let's do it like this instead. That's not what I want. Not at all. I would like this, I think. Yes. I don't really understand why this wouldn't work. Or maybe I do. Do we need to take these into account as well? Hmm. 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 Yeah. Okay, so all of these, the x and z coordinates, we always get 0. Do we always get something like this? This one takes out this one takes out this one takes out this one, so we only get a height difference. But that doesn't really explain. Nah, that doesn't explain this. Unless... okay. So I guess here we're getting... we don't have any difference here. So here we get 0, 0, 0. Okay, we can't do it like this. But what the fuck? If we just take... If we just take this one, and this one, we don't care about... Yes. So using these 3 we get the tangent, and using these 3 we get the... maybe we just want to use half, actually. Does that make sense? But then again... Then we don't really get... If we calculate the tangent using only those 3, we don't get the height difference we would see here. And I'm pretty sure we want that one to affect it. But... Or do we want to take... Diligence, humility. I woke up Saturday and was disappointed there were no stream. I appreciate it. Maybe in the future, who knows, who knows. I wonder if... Okay, so I want to get... When we calculate the tangent, I want to get the height difference for all of these points. I want all of them to contribute to the final tangent result. So I wonder, can we take this one minus this one minus this one, and this one minus this one? So we get, I don't know. The height difference is the interesting part. And then we add them all up. Or we just normalize them, basically. Yeah, but... Yeah. Let's try it real quick. But I also wonder if... Get neighbors clockwise. Oh, we actually get all neighbors. Yeah, I reckon we get a little bit of a smoother calculation. So we actually take these into account as well, even though we don't have a connection to them. That might be a little bit over the top. I don't really think we need to do it. It's a little bit of a smoother result, I think. I wonder if the reason... I'm having a hard time to remember, but it could be that we got a better edge result, because remember, this is like, it's a very specific case of calculating the normals and tangents. So maybe we got a little bit of a better result at the edges when we took all of them into account. But okay, so if we go clockwise, then we want to do okay, so we need to complicate this one a bit. So I wonder if we want to do terrain point P3 is equal to neighbors I plus neighbors count 0.5 times this one neighbors count. Parentheses can be removed. Yeah, I know. Oh, fuck it, let's remove them then. So what is the error we have? Cannot convert float to int. Oh, actually, yes. So 1, 2, 3, we have 8, so we do 0 plus half of 8 is 4, so 0, 1, 2, 3, 1, 2, 3, 4, 1, 1, 2, 3, 4, yeah, that should be it. But we also don't want to do it for we don't want to do it for all of them, right? So right now we loop through this. We don't want to go the full the full circle. We just want to take yeah, so let's do it like this for now. If I is less than neighbors.count 3.5, P1 vector, yeah, then we need to calculate P3 vector. Yes, and then we want to do a special case as well. I wonder how... Before we continue with that one, I just need to run AFK real quick, so I'll be right back. Okay, back. Sorry about that. It just feels like this method is becoming a little bit overcomplicated. And I don't really know how I want to handle. Let's just see if it works first, and then we can decide how to handle this case or the edge case for this one. So I wonder if we want to do and then we don't want to do this, but instead plus equals 2 P1 P3. Oh yeah. Okay, let's see what kind of result this yields. So if we're doing this correct, we're taking this point and this point, calculate a vector between them, then this point and this point, vector between them, this point and this point, vector between them, this point and this point, a vector between them, and then we're done. We add them all together and we normalize it. So 1, 2, 3, yeah, maybe. Better, but wrong. Fuck. From the normals and texture coordinates. using the vertex positions, normals, and the texture coordinates of the mesh. Interesting. Now I'm wondering if we're even getting the correct result here. Ah. Calculate tangent from vertex position, normal, and UV. Yo, what's up, Redstone? It's not too many, is it? Yeah, exactly. I'm after a very specific tangent. Okay, beautiful. We calculate the tangent for each triangle and then we normalize them. That should be us, or what we should be doing. And then we see what we need to do to handle the the edges. Beautiful. So vertex 1 minus vertex 0, vertex 2 minus vertex 0. Then we take the UVs as well. Oh, beautiful. Oh, fuck yeah. Okay, that's nice, but for now I just want to implement it, see if it works. and then alter it based on our edges. But we need to return, or we need to access the UVs. Luckily the UVs are they're static right now. I wonder if we want to change them. Nah, probably not. Let's see here. So what do we have? Terrain patch mesh data. Position normal tangent UV. We're gonna rework this one a lot in the future. We might want to lower the memory needed for a lot of these. At least for this one, I think. Like we might do with just UV actually. But let's see. Oh, public. So we just care about this one and this one this time around as well, and we only care about it in here. So what we want to do then is fuck, I want to get rid of this as well actually. I think we're gonna do this. And then we want to calculate the tangent. So let's see, P1 vector XZ. This we already do, but we do it the other way around. So we use that one in one place. We use this one in one place. We use this one in two places. Okay, let's do it like this for now. P1P. P2P. P1P UV. And then we want to get the UVs, so I guess we're gonna have to do... Oh, yeah. P1 dot terrain patch dot UV. Now let's clean that one up. Chords. Yes, and then let's see. The UV1, so that's this one, right? Mm. Beautiful. Edges fixed. Wow, what a great solution. Let's see. Yeah, nice. So our solution fixes the edges. Otherwise, it's the exact same as the Unity one. Okay, great. Thank you. Yeah. Okay, so now the tangent is... We have the correct tangent as well. Okay, that's beautiful. So let me just P1, P2. So this triangle, for instance, we take P1, P2, calculate this one, we calculate this one. Then we take the UVs. So the UV in X here times the UV, so 0 in Y here. Yeah, I'm gonna have to read up on that one later on. This one. But okay, this is great. Let's just fix it or make it a little bit prettier. I'm thinking when we get a vector from... We should be able to convert a terrain point to a vector easily. And let's see here. Chords UV. Terrain data type. Oh, not temporary, but water previous. Can't I do it like this? Derek checking in, what you're working on. We're working on generating the tangents in the correct way for the water. And we have finally done it. Now I'm just going to clean this up and we can continue. And I have to say, like, calculating the tangents is honestly, in my opinion, a little bit more complicated than I initially thought. but we also have the fact that we want to calculate the tangent in a special way on the edges of the water. So it was a little bit more of a mess than it needed to be, but we got it working right now. Fuck, we need height range here as well. That is true. Ah, no we don't. No we don't. Ah, what the fuck, we can just do it like this. Yes, here. Return. And then we do terrain patch, terrain patch. Oops. Terrain patch dot height range. Okay, I guess we're gonna make that one public. Or actually, one sec. Don't we have... what effects will you need the tangents for? That's a good question. So, we want to calculate the vertices making up the tangent space, and for that we need normals, tangent, and binormal. Binormal we get from tangent doing the cross product between tangent and normal, and we need this. We need these three because we want to create a transform matrix that brings something from tangent space to object or world space and the other way around. And we want to be able to do that because of this one. This one. So everything that involves reading data from tangent space, so everything normal map related. So normal map panning, and then we need it for refraction as well. It might actually help with having correct tangents, might help with some other stuff as well, but mainly this one and this one. Terrain data, what do we have here? We have get data. I think we eventually want to hide this one, if I'm gonna be honest. I don't know. Do we? And then we have public float value. One sec. Terrain point, terrain patch, and terrain data. I must say that the code base right here, it's messy for now, and I feel like I'm probably gonna have to take a session where we just go through them and reorganize it, the constraints and such, eventually. Terrain patch dot get value. Type x y. Excited to these effects in action. So am I. So am I. If we can get all of these working nicely, each on their own and together, it's gonna look beautiful. Okay, as vector, recalculate mesh data. Okay. What the fuck have I screwed up now? do. Diligence Humility, have you seen Nintendo suing Palworld, not for copyright but for patent? Yeah, yeah, I saw it, and Fabic mentioned it previously as well. Yeah, it's a shit show. So I just have to scratch my idea, because I also thought about catching monsters with balls in this game. Not really though, but yeah, it's weird. Just don't use a ball. Now we're gonna go with a cube instead. Should be okay, right? How the hell did I manage to fuck this up so badly by just going with as vectors here instead? What the fuck? Position OS. Position OS, position OS. Set mesh data. P vector. Oh. Hmm? Yeah. We want to do this. Terrain data type water. Okay. So okay, let's do this now. Quit this one. Procedural water terrain. Do we have water surface normal map? Yeah, let's use the only normal map we have right now. Put this one in here. Water surface normal map. We probably don't want to have it underwater. Oh, at water refraction. We probably want to have it at water general properties. Shadow amount. Vertical offset. I think so. Here. Why am I not getting... Why am I not getting my header, by the way? That's weird. Space, space. Water normal map, water surface normal map. Let's do... Go, and then I want to have water normal map, or actually, one sec. We get tiling and offset by default. How is it we use these values now? We need to define... Yo, what's up, Emmett? As soon as we click play, he's at, like, as soon as we click play, he's gonna get some nice apparel. It's just in the void here, he's undressed. Okay, so tiling and offset, access, tiling and offset, Unity HLSL. I never remember what variable they stored these in. Unity will set up a float called XST. Beautiful. So water normal map. Float 4 ST. Yes, and then we move these to general. Transform text. Yeah, I'm not using this macro, so okay, let's just do return. Oh, this. So we have UV scene center here. Now we don't want to use these ones here, so we could just do float 2 normal map UV, or actually is equal to float 2, and let's see how we want to do this now. Input dot UV dot X and input UV dot Y. We want to scale these and we want to offset them. But we could probably... t. X contain X tiling, Y tiling, and offset, offset. Okay. But yeah, I wonder if we can do it like this. Input.uv times water normal map st dot xy plus normal map st dot maybe return let's try this. UV scene, what the fuck? Yeah, I think I have. Okay, so this is a renaming done by mistake. We want to go UV, UV. Input UV scene. Let's worry about those first. Yeah, so this one here we want to use UV scene. We don't want to call this one UV scene and UV scene step. No, we're gonna do it UV terrain data. Okay, so we're naming by Control F2 and might want to be a bit more careful with that one. UV scene step, UV scene. I'm not so sure. We're probably going to move this block. So this block to the fragment shader eventually. But yeah. And then output UV is equal to input.uv. Okay, great. So input here, we just have the UVs. We don't return this one. So then we get down to here. We take the UVs we have, we scale them by the normal map tiling, and we offset them by the normal map offset. And then we sample the normal map and just return the value. I just want to see if we can get the tiling and offset correct. UVC in center. Okay. Yo, what's up, Cooler SK? Tiling 1 1, offset 0 0. Okay, so what the hell are we seeing here currently? What's a normal map? 2D. I just want to see what happens if we do input UV. What? Kuruska, how is the watering going? Pretty good. We haven't worked that much. Like, we haven't done that many water specific things today. We've done some prep work for the water. Okay, but what the hell are we seeing here? This doesn't make much sense to me. Input UV, have I screwed up the UVs for this one? UV text chord, and in the vertex shader we just send it onwards, and we set the UVs to be equal to set mesh data UV. So the UVs we have okay, I want to see what happens if we just handle this one as a default. Okay, makes a bit more sense. Terrain patch, water. Oh yeah, and then we go 10, 10. And we add back the UV normal map here. Okay, beautiful. So let's do calculate blend fong here. Base color normal. Okay, let's put this back to a normal map, and let's do cell shade lit. So we're gonna do this shit. We sample the texture and then we do this. Oh, we can probably... Okay, the reason we did it per channel here, we should be able to just create a matrix instead and just do a matrix multiplication. One sec, however. Whoa, one sec. I'm checking. Yeah, this... we want to do this. I thought it was a little bit weird that we... I'm still not entirely sure about... Okay, so we want to do this, but I'm not entirely sure why it's split up in this shader. And I wonder if get vertex normal inputs GitHub core vertex normal inputs. Do we have the definition of this one here? No. Okay, so that's all it is. Mm. Why did I do it like this? Why did I split it up? Is it because of this? No, 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 no. Tangent to world X. There must exist a cleaner way to create this. Train procedure water. Do we want to fix it in the vertex shader before we send it? I don't know why we would. But I'm like, if I were to do this, let's see, one sec. HLSL properties. No. Types. Oh, no. Let's do HLSL text chord. Semantics. There we go. What do we have? Binormal. Okay, I'm thinking of creating it like, I think in, let's see, procedural grass light. Here I think we're creating a nice TBN matrix, or are we? Tangent to world, yes. Tangent to world, where do we have it? There. Yeah, I think we just want to create one of these. Tangent to world. I have no idea why it did split it up. I wonder if it's... just some leftover code, basically. Okay, terrain procedural water. So the first thing we do in the fragment shader is sample text 2D. tangent to world. Oh yeah, and then we interpolate here, okay. But let's just do... Okay, so now we have a matrix that takes a point from, or a value from tangent space to world space. And then we sample the texture here. I don't want to... let's just do... yeah, let's do tangent to world and only with the RGB values. Let's see what we have, what we get. Here comes float 273. What am I missing? 3 times 3 matrix multiplied with, we just take the RGB values. Ah, yes, of course. Float 4 and 1. Yeah, that's not what I want to see. What the fuck is it? No. By tangent, world space, world space. Why do I get the feel that, let's see, terrain procedural water, UV normal map, we return, we multiply tangent to world, we read from the texture, water normal map, UV normal map. We take the RGB value, multiply it, so we should get it in world space. Could test normal map. It's a normal map. don't know about this. One sec. Rocco Zola. Thank you for the follow, by the way. Multitude cell shade strength. Fuck, let's do this as well. But still, I don't know. UV normal map, let's do float 3. Yeah, we want to unpack it as well. Chrome Dome, I will never be able to understand shaders. You will. Oh. Okay, now we unpack the normals. Okay. This is what I want to see, I think. Although... Zero, yes. Okay, so we can see here that we get, if we have a zero, like, okay, so like if we don't take the normal map into account at all, we just have the vertex normals here, and we can see that we have a little bit of a fade here and here, and that's good. Here as well, but it's not as apparent. And then we can control how much the normal map should affect it, okay? We can even go, we start seeing artifacts if we go extremely high. Not too sure about this one, so we're gonna fix these as well. Wanna avoid those. One. Wrap mode repeat. Why are we still getting? It might be an artifact at the texture. I tried learning, seems like I'm more of a software type of guy. Graphics programming is out of the question for me. I can relate, but then, like I think I took 2 courses in university that were solely focusing on like graphics programming, and I just fell in love, I suppose. I still think like functional programming, no, not functional programming, but when you do non-graphical focused programming on the GPU is also extremely amazing to me, like parallel algorithms and stuff like that. Rocosolo, same. I'm currently studying this kind of things in C++, and it is, I don't know how to pronounce that phase, but yeah. One day it might click and you might love it. Maybe. Okay, so now I want to start using this one. Still, does this look correct? I'm wondering. I'm questioning this, but that's probably an artifact in the texture. Can we zoom in here? One sec. Yeah. Oops. I think we have a line. It looks like we have some sort of line at the ends here. Okay. Oh well, it's just a test. So it's good, it's good. Okay, I want to, before we start distorting, or before we start implementing, yeah, is it distortion? No, refraction based on this normal map. I just want to see if we do lighting based on it, if it works as I think it would. So let's do, so we have the normal here. Let's return a Blinn Phong lighting based on this normal. So calculate blend Phong lighting base color. I don't know what we have here, but let's go with float. Util lighting. What do we do? Float 3. Yeah. Let's go with a. We have watercolor, shallow color. Okay. Shallow color. We have position in world space. Position in clip space, normal in world space. So we're just gonna send in normal here. Or actually, I want to rename this one. Normal in world space, view direction in world space, some constants. Water shadow suffers mother. Yeah, let's try this one, see what we get. View direction input. Redefinition. Okay. That's something left from previous iterations, I think. I think that's correct. Extremely boring color though. Oh yeah, we have ambient. What do we have? Ambient, multiplier, and specular. Ambient. Yeah, we probably want to go 0.5 now, 1. Okay, I can see that the specular highlights are working-ish. We can see it here and here. Could probably shadow amount. Let's see here. Shadow amount, smoothness, specular, ambient, multiplier. Yeah, 1, 1. So what if we go 0.5 smoothness? Okay, yeah, I think it works. I'm questioning the dark side of this. Why are we getting... Why is it so dark here? That doesn't feel correct, right? Let's return the normal again. Oh yeah. Oh yes, 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 yes. Of course. Okay, so now we're just showing the normal from the texture. We want to do... we want to multiply this. Actually, let's do it like this. So we unpack it, and then we want to do mul, and we want to multiply it with the tangent to world matrix. And then if we return normal VS, now we get this, And if we comment this one out, so now we calculate Blin Phong with world normals, we get this. Beautiful. This is what I want to see. And if we do, let's put this one at 1 again. Okay, beautiful. Okay, so what we want to do now is based on these normals, we want to recalculate, or we want to like distort the UVs, which we read from scene color width. So when we fetch whatever color we have underneath this water here, because currently we're reading the scene color texture. So when we have rendered every opaque object, we take the output and put it into a texture, and we read that texture back here, but we want to distort it a tiny bit based on the normals. And I think HLSL reflect. No. This, when we work with reflection, we want to use this one. Refract. An entering ray, a surface normal, and a refraction index. I wonder if we want to rely on this one. Would love a better or some figure would be amazing here. Refract. Oh, one sec. Okay, so they've just taken... Do I dare? Ah, thank you. Yeah, this is what we want to use. So we get this one, and then we can use the I wonder if we can use just the X and Z values as our offset values to when we read from the UV. We might want to use depth as well. Let's try it. Let's try it. Watercolor, water refraction. What was the fancy word they used for it? I don't know if it was that fancy refraction index. Yo, what's up, modding Minecraft, working on spheres, question mark? Nah. Still water. Refraction. I wonder if I want to use the prefix water for everything water related in a water shader. It could become redundant, but I'm afraid that we're going to introduce a lot of properties later on that are not specifically tied to water. Water refraction index. Water should have a physically defined refraction index constant, right? So we might as well just hard code it here eventually, but I want to do some testing. One sec. Water refraction index. Okay, it's based on temperature as well, yeah. But 133. Let's just put that as the default. Okay. Distortion power n.v. Yeah, this is not how I want to do it this time around. So yeah, let's do. Yeah, I relied on n.v here. I'm not so sure that was the best option. Let's do float 3 refraction direction. Refract. Ray direction. And here we have input view direction in world space. And then we have vector. Normal in world space. And then we have refraction index. So then we get refraction direction, and now we want to use this one to alter the UV. We have UV scene center here. Pixel outline data distorted. UV scene center distorted. Yeah. UV scene center. Then we use distortion, vertex, normal bounds. Yeah, I don't want to do that. So instead, let's just do UV scene center plus float 2 refraction direction dot x refraction direction dot z. Water blurring 0, or are we blurring here? I don't know. Return. So if we do 0 here, do we have any refraction? Okay. Do we want refraction direction? Do we want to do, let's see here, view direction world space safe normalize? Do we want to do the safe normalize? Maybe we want to move these up. Because I'm looking for a refraction index value which leaves us with no refraction, pretty much. View direction world space. I don't know about this. Okay, this looks a little bit better, I would say. But what's going on here? Normal world space, return. Yeah, this is not what I'm anticipating. If we do... Okay, the way I want this to work is if we go with a water normal map strength at 0, I don't want to see this at all. Unpack normal scale. Looking for in-depth info. So am I. Oh, yes. One sec. Sample texture 2D, unpack normal scale. If we don't care about the scale, we just get this. as I don't know if that's needed. Okay. The refraction is still incredibly strong. 0.1, 0.1. Better, but nah. It still worries me that we have to go with this low of a refraction value to get the correct values here. It feels... maybe it's an extremely strong normal map, but... or actually, yeah. Water normal strength, refraction index 0. Yeah. This looks... Where are we getting this strong of a refraction from a normal that looks like this? Hmm. View direction. Okay, let's do water refraction index 133. Feels let's see. I just want to introduce a water refraction index. Water ref. And then I want to use this one when we do this. So we do this one multiplied with this one. Maybe. One sec. Oh, do we need to normalize? What do we have here? It's definitely too strong, but let's see here. And then we do water refraction strength. I don't buy this refraction here. What the fuck are we moving? No. So this refraction here, okay, adding to the x, or adding the x and z to the UVs is probably not correct. Return. Yeah, let's skip all of the other calculations for now and just return. Where do we have it? Sample texture 2D. Scene texture. Yeah, get the fuck out. What? Normal world space is fine. View direction world space. What do we have? One sec. Okay. I think view direction in world space is okay. Normal in world space is okay. It's a conversion when we go from, when we do this, we need, I think we need to transform these. Or do something with them before we use them like this. But wondering if... What am I misunderstanding here? We refract view direction. It's in world space. We should be getting a refraction direction, and then we use the X and Z there. It's in world space. I don't really see... where all of this... or like where the wrong calculation is. UV scene center. Screen space. Refraction strength 0, which means that we should be getting... Oh. If water refraction strength is 0... Fuck. Oh, one sec. UV scene center distorted. We don't change this one. No, we don't. UV scene center. Okay. Distorted. UV scene distorted, UV scene center plus water refraction strength. Okay, have I This one should be 0 right now, but it doesn't seem to be. Water refraction strength, here we go. This works. Water refraction strength. Oh, am I? Yeah. Okay, what am I missing? I don't know about this. Are we getting a very small floating point issue? 0.0101. Okay, I have no idea what the fuck is going on right now. Now it seems to work. Only there, however. Seriously? Okay, interesting. Hopefully I can make sense of this tomorrow, because unfortunately I need to run now, but yeah, this all seems very strange to me. I must be doing something very wrong. somewhere. We'll probably get to the bottom of it tomorrow. But I gotta run now. And this is going to annoy me until tomorrow. Yeah, same here, Derek. Can't wait for it. This is doesn't make much sense to me. I'm pretty sure we will get to the bottom of it tomorrow. Thank you so much for watching, everybody. Appreciate it. And have a great rest of the day. Peace.